Okay, here we go. I want to take you through 1.5 day 2. This is a little bit more of a difficult question, and it's very similar to some of the questions we've done earlier in the chapter when we talked about, there was a question, I believe it was lesson 1.2, number 16, that talked about Ramona investing $5,000, part of it at 5%, part of it at 7.2%. This is very similar to that type of question, same approach. Again, like I covered in 1.5 day 1, we want to be careful when we're reading the question to look at the question, how much of each alloy. So you'll notice in my let statements, I put this in bold. You don't have to put this in bold in your answers, but I'm just trying to highlight that for you so you understand how important that is to have the proper math language in your let statements, because it affects or influences the equations we need to come up with. So the question is asking us about metal alloy. One metal alloy is 25% copper. Another alloy is 50% copper, and how much of each should be used to make 1,500 grams of a metal alloy that's 40% copper. So alloy just means it's a mixture. It's not a pure, if it's a gold alloy, it wouldn't be 24%. It wouldn't be pure gold or 24 karat gold. It would have some other alloys or metals mixed in, like a nickel. Right? A nickel is not 100% nickel. It may have some other materials in there. For example, aluminum or some other steel, something in there. As part of it. It's not a pure mixture. It's not a pure metal. The way I like to teach this, though, is to think about chocolate milk. If you had a container, 2 containers in your refrigerator, and one of them was a container that had chocolate milk, and it was 25% chocolate, and another container had a chocolate milk at a concentration of 50% chocolate, and you want to make 1,500 milliliters. I know this one's about grams, but think chocolate milk. 1,500 milliliters or 1.5 liters of chocolate milk, but you want your chocolate milk at 40% chocolate. You don't like 25%, it's too weak. 50% is too sweet, but you like your chocolate milk 40% chocolate. That's kind of like this question, but just talking about copper alloy. So think of something that makes more sense to you, maybe more applicable, but the same approach, okay? So in this case, the first equation we want to come up with, again, the let statement, let X represent the amount of 25% copper alloy we have to use, and Y is the amount of 50% copper alloy. To use the chocolate milk example, we're going to have to pour some of the 25% chocolate milk and some of the 50% chocolate milk containers, some of each, and get 1,500 milliliters. And once we mix those two in the right proportions, we're going to have 1,500 milliliters. That's going to be 40% chocolate. But how much of each do you use? So we're using the variables X and Y here. And I know that X is the amount of the 25% copper alloy. Y is the amount of 50% copper alloy, and the total amount that I need to make is 1,500 grams in this case. We don't write G next to it. We don't write grams, millimeters, centimeters, kilograms, anything like that in the equations. Those we save for, all that information we save for the therefore statement. All units of measurement go there. So please don't add those to your equations. The second equation is all about the copper content. So we don't know how much of the 25% chocolate milk container we need to use. Maybe we're going to use 500 milliliters. Maybe we're going to use 800 milliliters. Maybe we're going to use 1,000 milliliters. I don't know. But it doesn't matter what amount we take from that container, whether we take a little tiny bit or we take a whole cup or a liter worth, it doesn't matter. Whatever proportion we take from there will be 25% chocolate. So that's what our next statement is going to be. So we're going to have 25%. We convert our percentages to decimals. So it's 25% of the amount that we take from that container is going to be chocolate, plus 50% of the other container is going to be chocolate. And here's probably the hardest part of the question. How much of our 1,500 grams, in this case, has to be copper, right? Because this is the copper content. 25% of that amount is copper. 50% of the other container, of whatever we take from that container, is going to be copper. And how much of the 1,500 has to be copper? Well, 40% of it has to be copper for it to be a 40% copper alloy. So in that case, we have to actually multiply that by 0.4, or 40% of our total amount must be copper. Again, think about that, right? At the end of the day, the second equation is all about the copper content. The first equation is just basic amounts. This amount plus that amount is a total of 1,500. The second equation is all about the copper content in each. So in order for us to go further, I'm just going to rewrite number 2, and I'm going to write 0.25x plus 0.5y is equal to, and then we have to figure out what 40% of 1,500 is. You can use your calculator, but 40% of 1,000 is 400. And so another 40% of 500 is another 200. So altogether, that's 600. Again, you don't write grams or anything yet. So that's 600. That's really what the equation is. You don't need to write this if you don't want to, or the second portion, sorry. You could just skip right to 600 the first time around. But as you get more comfortable, you might skip that step. But for now, maybe you appreciate the multiple steps here. So the two equations that I'm really looking at now are my new number 2 here and my number 1. Those are the two equations I want to work with right now. And when I look at that, and again, most of you will look at that and say, hey, great substitution question. I'm going to make that x equal something, or I'm going to make that y equal something. Go for it, get it done, no problem. I prefer to use elimination, so I'm going to lean towards elimination here. And to do elimination, I have to think about this a little bit more. If I want to do elimination, I would need to make the numerical coefficients the same on the x and y. The x has an invisible 1, the y has an invisible 1. But then I'm stuck with 0.25x and 0.5y. And if you've seen enough of these questions, you start to see a little bit of a pattern. And so from my experience, I know that I can multiply this second equation by 4. And that's going to help me out. Watch this. So now my new number 2 equation, I'm going to erase the highlight on that one. My new number 2 equation is going to be 4 times a quarter is really just 1x. So I don't write the 1. 4 times 0.5 is going to be 2. So that's 2y. And 4 times 6 is 2,400. And that's my new number 2 equation. And I'm just going to bring that equation down here. I'm going to write it again so I can work with it more closely. And that was just x plus y equal 1,500. And now my x's are the same. If I subtract x minus x, I get 0. 2y minus y is just y. And 2,400 minus 1,500 is 900. I find that a lot easier. Again, if you're familiar with the questions and do your homework, you'll see this pattern where you can solve by elimination a little bit more quickly. Now, of course, we have to solve for x. And the simplest equation I can use here is x plus y equal 1,500. So if we know that y is 900, we'll sub that in with brackets, equal 1,500. And then x has to equal 600. Box your answer. And then I went ahead and did a therefore statement down below for the sake of time. Therefore, 600, and here's where I need to write grams. 600 grams of 25% copper alloy should be mixed with 900 grams of 50% copper alloy to make 1,500 grams of a metal alloy that is 40% copper. I hope that helps. And we'll see you guys soon. Good luck with the homework. Come on in for any questions.